Would you like to master Excel charts and graphs?
Want to learn Python but worried about how to get started? Udemy makes it incredibly easy. Now you can learn Python with in-depth online courses.
Hello guys, this is Code and Code, and this is going to be a lecture series on graph theory. And this is going to be there are going Hello guys, this is Code and Code, and this is another lecture of this graph theory series. And in this lecture we are going to study about cycle detection using DFS. So let's get into the lecture. So this is the problem statement. You are given a graph and you have to find whether the given graph contains a cycle or not. So if we see an example, then this graph contains no cycle, while this graph contains a cycle, which we can see here, a cycle between node 2, 3 and 4. The speciality or property of cycle is that it provides alternate path to go from one node to another. For example, take an example of this graph. If you find how many ways are there to reach to node 3 from node 1, there is only single way. You have to go from 1 to 2 and then 2 to 3. Same goes for any any pair of node in this graph. If you choose any pair, then there exists a unique path between those two nodes. For example, node 3 and 4. The path from 3 to 4 or 4 to 3 is 3 to 4 or 4 to 3. There is no alternate way. But when there exists a cycle in the graph, then it creates alternate ways to go from one node to another. Take an example of 1 and 4. There is a path from 1, 2 and 4. This is a single path, and then there exists another path that goes like 1, 2, 3 and 4. To reach 4 from node 1, there are two ways now. If there wasn't any cycle, let's say we remove this edge, then there would be a unique path from node 1 to node 4. So this is a property of a tree, that in a tree, for each pair of nodes there exists a unique path, while if the graph contains a cycle, this is not the case anymore. So let's look at some terminologies, and then we will start and see how we can find whether the graph contains cycle or not using DFS. So the first one is parent. So this node 5, is currently the function on which DFS is being performed, and node 4 has made a DFS call to node 5. So you were at node 4 and then you made a DFS call to node 5. Since this node made a DFS call to node 5, hence this is the parent of node 5. So if node 2 makes a DFS call to node 4, then node 2 becomes parent of 4. And the other thing is back edge. So suppose we made a DFS call to 1 and then 1 made a DFS call to 2, 2 made a DFS call to 3, in turn 3 made a DFS call to 4. Now you see this edge connects node 4 to one of its ancestor which is not its parent.
Hi! Have you always wanted to learn to code but don't know where to start? Would you like to make
any edge that connects a node to its ancestor which is not its parent, that edge is called the back edge. And if you find any back edge in the given graph, that indicates the presence of a cycle. Let's see how. So to reach node 4, let's take an example of this. To reach node 4 from 2, you already have a path because you made a DFS call and then you reached node 4 using its parent. So there exists a path from node 2 to node 4 which doesn't include this edge. So there is a path from 2 to 4 which doesn't include this edge because you reached node 4 without using this edge. You reached node 4 via its parent which is 3. But if you include this edge, then there exists another path from its ancestor to node 4 directly, which indicates that there are more than one path from two in this pair of node, and hence it indicates the presence of a cycle. So all we have to look for are the back edges. So in the given graph, if there exists a back edge, then the graph contains cycle. So all we have to do is whenever we are making a DFS call, we would pass an extra argument, that is the parent. So in the adjacency list of 4, there are 3 edges. First edge connects 3 and 4, and that is visited. Visited node indicates the parent or ancestor. So since 3, 2, 1 all are visited, all are ancestor of 4 for now, and since node 3 is also visited, but this edge is not back edge because it doesn't connect node 4 to its ancestor which is not its parent. It directly connects node 4 to its parent. So if there is a node which connects node 4 to or any node to its parent, that edge would not be considered as back edge. So this edge is not back edge because it connects node 4 to its parent. That is why in the DFS call we also need to pass the parent node. So we can check in the DFS function that whether the visited node is its parent or not. So since this edge connects node 4 to its parent, it is not a back edge. Then in the adjacency list of 4, there is 2 as well, and 2 is also visited. So we would look whether 2 is parent of 4 or not. But this time 2 is not the parent of 4, and hence it have to be ancestor of 4, and hence it indicates the presence of back edge, and that is why we would know that yes, the graph contains a cycle. So this was all the theory part. Let's take an example and make things even clearer. So this is the graph, and this is the visited array to indicate which node has been visited or not, and it would also tell whether the graph is whether the current node is ancestor or not. This is the adjacency list, and this is the stack. So from the main function we made a DFS call to node 1, that is why in the stack there is DFS1, and we also passed parent of node 1. Since in the DFS call now we are passing two things, node number and the parent of it, and since this is the root for our case, because in the main function we are making a DFS call to node 1, so node 1 is root, and since there are no parent of any root, so we would simply pass -1. In the adjacency list of 1 there is 2, and 2 is not visited, so we would make a DFS call to node 2, and as a parent of node 2, we would pass node 1 because node 1 is making a DFS call to node 2. So as soon as we reach node 2, we make it visited, and we have passed 1 as its parent. In the adjacency list of 2, we have 1, and 1 is already visited, so we have to check whether this edge is back edge or not. For that, we have to check whether this edge connects it to node we have to check whether this edge connects node 2 to its parent or not. For that, we would check whether 1 is its parent or not, and as 1 is its parent, hence this is not a back edge. So we would continue, we would move to node 3, and since node 3 is not visited, we would make a DFS call to node 3 and pass 2 as parent. In the adjacency list of node 3, we have 2, and 2 is already visited, so we would check whether this is back edge or not. And since parent of 3 is equals to 2, and hence node 2 is parent of 3, hence this cannot be a back edge, and hence we would continue. So we would come at 4, and we would see that node 4 is not visited, so we would make a DFS call to node 4, passing 3 as its parent. In the adjacency list of node 4, we have 3, and since 3 is visited, so we will check whether 3 is its parent or not, and since 3 is its parent, so it cannot be a back edge, so we would move on. We would go to 2, and since 2 is also visited, we would check whether 2 is 4's parent or not. Since 2 is not 4's parent, hence this edge is back edge, and hence this indicates the presence of this edge is 4's parent or not. Since 2 is not 4's parent, hence this edge is back edge, and hence this indicates the presence of a cycle. As you can see, node 2 is not the parent of node 4, hence it have to be a back edge, and hence this indicates the presence of a cycle, and hence we would return true from here, and we would not continue its execution. Instead we would return 1, that would indicate that yes, we have found the cycle. As soon as node 3 receives true, it would return to its parent, and then that would return its parent, and this node 1 would return in the main function that yes, we have found a.
Have you ever noticed how some people just light up a room from the moment that they walk in? Now,
cycle. And this is the implementation of cycle detection using DFS. So we have a function DFS that takes 2 arguments, node and the parent of the current node, and it returns bool value true if the graph contains cycle and false otherwise. As soon as we reach this node, we would make it visited, and then in the adjacency list of this node, we would see whether the given node, or whether the node in the adjacency list of current node is visited or not. If it is not visited, we would make a DFS call to this child, sending the current node as parent, and if it returns true, which indicates that the sending the current node as parent, a DFS call to this child, sending the current node as parent, and if it returns true, which indicates that the graph contains a cycle, and hence instead of continuing our execution, we would return true from here. If the child, that is the node, is not visited, then we would check whether it is equal to parent or not. If this is not parent, then it have to be a back edge, the current edge have to be a back edge, and hence we would return true from here. Otherwise, if the complete execution of this portion executes successfully, then we would return false, indicating that yep, we have found no back edge, hence the graph doesn't contain any cycle. So this is the code part, and I hope you guys